So what can I do with an object once I have it? Well, that depends on its methods. A method is the name of a kind of clause. So define class has a pretty small number, like half a dozen or so, kinds of clauses, and each one starts with its name. So method is a kind of clause that's in a defined class. And the syntax, again, is meant to look like the syntax of lambda. So if you imagine for a moment that this says lambda, then inside these parentheses here would be the formal parameters. I'm sorry, not the lambda. I take it back. Blah, 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 back up. Like define for procedures. So if this said define, we'd be defining a procedure named magnitude with no arguments, right? And this would be its body. A method is exactly like that. It is making a procedure, but it's not doing it it doesn't give it a name in the same way that define does. But we can use these this way. I can say ask, which is one of the 4 pieces that make up this implementation. And now I put an object. Ask is an ordinary procedure. So this thing, C1 here, that gets evaluated. It happens to be a variable whose value is an object. But I could have said ask, parenthesis, instantiate, blah, blah, blah. And that would work too. And I'm going to send it the message magnitude. And magnitude doesn't require any arguments. So that's all I have to say. And it tells me 5, which is the it's the square root of 3 squared plus 4 squared, right? Which is what this says to do. Right? Because real part is 3, 3 squared is 9, imaginary part is 4, 4 squared is 16, 9 plus 16 is 25, the square root of 25 is 5. And we can say ask C1 quote angle, and it's 9.927 blah, blah, blah radians. In our object system, we provide automatic messages and methods to look at the values of these variables. So I can also say ask C1 quote real part, you get the answer 3, and similarly imaginary part will tell me 4. Okay? That's just a design decision that we made. Many other object systems do things differently because there's a whole other story that you might hear about object-oriented programming that revolves around the idea of information hiding. And that story goes like this. The way you get bugs in programs is this piece of the program does something that affects the behavior of that piece of the program in ways that you didn't intend. And this and that are widely separated in the code, and so you don't catch the dependency. And to prevent that, what we do is we build a wall around each object class so that nobody else can look inside it at the values of its variables, for example, unless there's an explicit method. So when you're designing a class, you get to say exactly how somebody outside the class can interact with you. That's the right way to think about object-oriented programming if you're on a team of 5,000 programmers, writing a huge project, where it's easy for you to write code that steps on someone else's toes or vice versa. So everybody builds a wall around their thing and says how you're allowed to interact. You guys are not going to be in teams of 5,000. You're going to be in teams of 1 or 2. So that problem doesn't apply so much. And as I think I said once before, your programs are never going to get into production. You're interested in your program only as long as it doesn't work. So the goal of our language is to make debugging easier rather than to hide information. So you just automatically get ways to examine the values of every variable of every object. Yeah? is each class acting like an interpreter? Well, only in the sense that its methods are scheme code, right? The way you actually run the program, it could be interpreted, it could be compiled, so each class could turn into, machine language. That has to do with the underlying scheme implementation. I don't know if that answered what you mean or not. Let's go on and we'll see. Other questions? Okay. Okay, so far, this example doesn't do anything that we couldn't do before. You've seen, in fact, precisely this example near the beginning of chapter 2, where a complex number was created with a real part and an imaginary part, and you had procedures called magnitude and angle that would take a complex number and do precisely these computations. So all we've done is taken something that we knew how to do already and recast it in the language of message passing. Let me just say a word about this quotation mark right here. It means what it always means, namely the thing that comes after it is the actual datum that we want to use. Generally speaking, that's how messages are going to be presented in your code. That is, when you're writing the program, you know what message you want to send an object, and you want to put that message right in your code. And the way to do that is to make it data, which is to say you quote it. But I don't want any of you developing mystical ideas about how the quotation mark is part of the idea of being a message. A message is just a word, and I could have said ask C1 word quote quote real quote minus quote part. Oops, I spelled it wrong. Okay. Ask C1 word quote real quote minus quote part, and you would say 3. All right, so don't get hung up on the quotation mark. It means what it always means in scheme. Yeah? Okay, the question is, why don't I have a method real part? And the answer is, again, in this particular object-oriented language, we automatically generate those methods for every variable of an instance. Okay? So it's just as if we had said method, open paren, real part, close paren, real part. But we provide those automatically for every variable. Okay? And we do that, again, because it makes debugging a lot simpler if they're just automatically there. We don't provide automatically methods to change the values of variables. Most OOP languages don't do either one. You have to provide methods both for looking at and for changing variables. Our choice was, we could have provided both of them automatically. We could automatically make a method called setRealPart, but we decided it should be easy to look and not quite so easy to tinker. That was our design choice. Okay.